2.3. Identify Planck's hypothesis that radiation emitted and absorbed by the walls of blackbody radiation cavity is quantized. One of my favourite scientists, Max Planck, a German scientist who came up with the beginnings of the quantum theory. So in 1900, Max Planck proposed a radical new theory to explain blackbody radiation. He found that the only way to explain the exact details coming from the experiments was that energy was quantized, emitted or absorbed like little packets called quanta. The existing theories of classical physics assumed that the amount of energy carried by a light wave could have any value on a continuous scale. However, Planck's theory was that the energy could only take certain values based on units or quantum energy. And I'll get you to underline that sentence there, and that's why it's on a new line. So Planck's quantum theory proposed that the amount of energy carried by a quantum of light is related to the frequency of light, which is E equals hf, where E is the energy of quantum in joules, H is Planck's constant, which is 6.626 times 10 to the negative 34. The value that I've got there is incorrect, and it's been updated to 6.626 times 10 to the negative 34, where that is represented by H, and frequency is a value in hertz. You may have seen a similar equation in year 11 where we use V equals lambda times frequency, or C equals lambda times frequency, which you need to also have that in your books. So he was a successful scientist at the time, and he was having the ideas that inside the atoms there was oscillating back and forth, therefore emitting radiation in a similar way to a radio antenna. So like antennas, the oscillating atoms could also receive electromagnetic radiations from their surroundings. The revolutionary idea in his explanation, however, in order to explain the pattern of emitted radiation were that the electromagnetic energy associated with the oscillation of atoms was quantized. So it relates back to that equation in E equals hf. So quanta of energy were absorbed or emitted only when an atom changed from one quantized energy level to a different quantized energy level. If the atom did not change quanta levels, it could neither be absorbed or emit energy. Because of the amount of energy absorbed or emitted, when the electron's charge quantum levels is so small, the unit we use when we deal with quantum of energy is the electron volt, E equals capital V, where that equals 1.6 times 10 to the negative joules, negative 19 joules. Or you might have seen it on my posters as E joules equals 1.6 times 10 to the negative 19. Okay, so there is a graph here that is in the worksheet that I haven't put on this slide that I'd like you to copy down in your books, and it'll come up in these next few videos. However, the one in your worksheet 12 is key for your notes.